All right, for number 5, again, we're doing more factoring. Lots and lots of factoring everywhere. Here, our two terms have sign in common. So, just like with that cosine problem, if you want to work it like this, I think that can be helpful just to show yourself. When we take out a sine, we have secant left. When we take out a sine from that second term, we have 1 left. All right, so sine of x is equal to 0. And secant of x is equal to 1. It's a little faster than our other factoring problems. Sine is 0 at 0 and pi and 2 pi. Secant is 1 where I don't really like thinking in secant. I like thinking in cosine. If secant is 1, that's 1 over 1. That means cosine is 1. And cosine is 1 at 0. And you can list 2 pi as well. So this is a kind of funny situation where we can do one equation and get all of the solutions. If we do 0 plus pi k here, that gives us all of the coterminals for 0, pi, and 2 pi, and etc. So that's number 5. All right, number 6. More factoring, more GCF. It's really important to be able to GCF in a reasonable way. Here I have secant in common. Make sure you're writing those variables. It doesn't make any sense if you don't. So now that this is in factored form, we can set each piece equal to 0. Secant of theta is equal to 0. Here, if we subtract the radical 3 over, cotangent of theta is equal to negative radical 3. I prefer not thinking in secants and cosecants and cotangents. I prefer thinking in cosines and tangents and sines. So I'm going to flip these. Cosine, if secant is 0, that means cosine is 0 over 1. I'm sorry. If secant is 0 over 1, then cosine is 1 over 0. Now, that is undefined. Cosine is never undefined. And so this does not give us a solution. This part of the equation is one of those parts of an equation that's just not going to give us a solution. But it's really good to talk about secant and 0 and cosine and undefined there, because I think it's very easy to make the incorrect jump that if secant is 0, then so is cosine. So make sure whenever you have that whole number, you're putting it over 1 in order to flip it. For cotangent, I'd rather not think in cotangent, I'd rather think in tangent. So if cotangent is negative radical 3 over 1, that didn't work the way I wanted it. Then tangent is negative 1 over radical 3. Remember, to make that a ratio that we're used to seeing, you would want to rationalize that denominator. There are those radical skills that I said were important. And now we can think about tangent. So tangent is radical 3 over 3 at our sixths. And tangent is negative in quadrants 2 and 4. In quadrant 2, our sixth is 5 over 6. And in quadrant 4, our sixth is 11 pi over 6. Now, make sure you draw your diagram for this if you're going to do plus pi k or plus 2 pi k, because these two do make a straight line. So our equation for all solutions to pick up all the coterminal angles looks like this, just plus pi k. So for tangent and cotangent, you're definitely going to be looking for that plus pi k when you solve. All right, I'm going to roll, I think, with at least one more on this video. 3 cotangent squared minus 1 equals 0. I would not, although I do love a good factoring problem, I would not try to factor this one. I would add 1 to both sides. divide by 3. And take the square root. Now when you take the square root of both sides, when we're forcing a square root like that, we have to do plus and minus. And I think it's helpful just to do the square root of the top and the square root of the bottom to make sure that you don't forget a square root somewhere that you need it. And here, if you don't want to rationalize, so that would be square root of 1 is 1 over square root of 3. If you like to think in tangent, like I do, instead of cotangent, don't rationalize it, just flip it. Square root of 3 over 1. So tangent is square root of 3 at all of our thirds, and here for this problem we have plus or minus, so we really need all of our thirds. So our first quadrant third is pi over 3, our second quadrant third is 2 pi over 3, and the third quadrant it's 4 pi over 3, and then the fourth it's 5 pi over 3. We can definitely condense this into 2 equations for that general formula. The general formula to pick up all the solutions, I would just kind of draw your lines. Pi over 3 and 4 pi over 3 are on that same line. So if I write pi over 3 plus pi k, that's going to pick up pi over 3 and 4 pi over 3. 2 pi over 3 is on the same line as 5 pi over 3. So if I do 2 pi over 3 plus pi k, that picks up 2 pi over 3 and 5 pi over 3. All right, so that was 5, 6, and 7. Getting there.